Hello everyone, welcome to the video lecture on GPAT 2020 question and answer explanation, and in this video I am going to explain the questions from medicinal chemistry as well as pharmaceutical analysis. These are my channel credentials. I have more than 1300 subscribers, more than 25,000 views, more than 80 videos uploaded related to pharmacy content. If you like the video, do subscribe, like and comment about the video. Let's begin. Now, at the beginning I am going to deal with questions related to medicinal chemistry. The first question is a 4-aminoquinoline anti-malarial drug that has true trifluoromethyl moieties at 2 and 8 position and no electronegative substituent either at 6 or 7 position is. What is the drug which has got all these properties? This question is related to structure activity relationship. Now, this anti-malarial drug is a quinoline derivative. Now, quinoline ring is this one. Now, in quinoline, the positions are, this is 1, 2, 3, 4, 5, 6, 7, 8. Now, question they're asking about, it is a 4-amino derivative. At 4th position, you have substitution is there, and at 2nd and 8th position, a trifluoromethyl groups are present, and at 6th and 7th, no electron withdrawing group is present. No group is present at these two junctions. What is the drug? Now, look at the options: primaquine, chloroquine, mefloquine, amidoquine. All of them are anti-malarial drugs. In order to answer this question, you have two approaches are there. One, you need to know the structures of all these drugs. Two, you need to think logically. Without knowing the structures, you can answer this question. How? Look at the answers: primaquine, chloroquine, mefloquine, amidoquine. The reason why it is called as mefloquine indicates you have methyl fluoromoiety is there. That is the reason why it has got the name. No other drug has got the things. Now, what is the question about? You need to get a drug which has got trifluoromethyl substitute, and this is the only drug which has got fluoromethyl substituent is there. Now, analyze this one. Without knowing the structures, you can answer it when you think logically. Let us see about the structures. Look at the structures. All of them are anti-malarial drugs which are quinoline derivatives. Now, you have 4 amino substituents are there, and this one is 8 amino substituent. Look at them. The numbering starts from here, so this one becomes 8 and this one becomes 4. Now, 8 amino only primaquine, palmaquine, plasmaquine are there. Remaining chloroquine, amidoquine, all of them are 8 amino substituents. Now, when you see the mefloquine structure, at 2 and 8 positions, you have trimethyl substitution is there. See, 2 and 8. It says at 6 and 7, no electron withdrawing group is there. Why 6 and 7 are important? Because for the rest of the drugs, at 6 and 7, you have electron withdrawing group is there. See, at 7th position, electron withdrawing. At 7th position, electron withdrawing. 7th position, electron withdrawing. 7, electron withdrawing. But it doesn't have it. So this drug stands outside from all this pattern. It doesn't has got 6 or 7 electron withdrawing substituent, but it has got 2 and 8 trifluoromethyl substitution. Answer is mefloquine. Now, analyze this question. So, in GPAT, you can get correct answers if you think logically, and you need to practice this kind of analysis. Moving further, now the next question: the heterocyclic nucleus present in nitrofurantoin R. That means they're talking about nitrofurantoin drug, and you need to know what all the heterocyclic rings are there. Now, see, nitrofurantoin indicates you have nitro group is there and furan, right? So most of the options has got nitrofuran. This one, no nitro is there, only furan is there. That indicates you can eliminate this answer because the question itself says the drug has got nitro and furan, and it says only furan, so this is eliminated. Now, remaining 3, if you need to give a correct answer, you need to know the structure. So this one is furan, and at the 2nd position you have nitro group is there. See, they're talking about heterocyclic nucleus. You need to think about this nucleus individually. If you see the numbering, the nitro will get, the numbering starts from here 1, 2, and you will get 5th position. But when you think the nucleus separately, then it becomes 2 nitrofuran. Now, so this one is eliminated because this one is 3 nitrofuran. Now, out of these two, this one is imidazole 2,4-dione, this one is only 2-one. When you see this, this is 2,4-dione. So the answer is this one, 2 nitrofuran, imidazole 2,4-dione. Now, to answer such kind of questions, you need to know the structures. Next one, riboflavin chemically is. Again, this is a structure related question. Riboflavin is made up of 2 units. What are the units? You have ribitol sugar is there, and this one is a flavin nucleus. Flavin nucleus is isoalloxazine nucleus, and in this the numbering starts from here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, like this it goes on. Now where do you have the substitution? At 6 and 7 you have dimethyl substitution is there. Now look at this one, 6,7 dimethyl isoalloxazine. You're talking about this one. 8, 9, no. 8, 9, no. See this one, 6, 7, it says diethyl. The substituent you have is dimethyl. So the answer is the first one. So for this, in order to answer this again, you need to know the structures. Next one. The weakly acidic nature of warfarin is attributed to the presence of. Now this is a kind of concept oriented question. You need to know the structure and you need to know acidic nature of the hydrogens. Now before looking at the options, let us see the structure of warfarin. Now warfarin can exist in two forms, keto form and enol form, and the numbering starts from here, 1, 2, 3, 4, like this. So see, this is a tautomer. The tautomer's ketone is more favored. The reason why keto form is more favored is this is thermodynamically stable. So though it can exist in two of the isomers, it wants to be in keto form because it is more stable. Now in this you need to know which hydrogen has got highest acidity. Look at the options. Proton on chiral carbon. Now see, this one is a chiral carbon. Now proton is there. Now understand the concept of acidic nature. If that proton comes out as H+, it will be leaving a negative charge here. Now you need to have certain charge stabilizing factors in order to show its acidity. Take a simple case of HCl. HCl acts as an acid because after leaving this H+, Cl gets this electron and the electron cloud is stabilized because of electronegativity of chlorine. If such kind of stability is there, it becomes a very good acid. Now if this hydrogen comes out as proton, it leaves a negative charge and there is no stability pattern exists here. So this is not the correct one. Next, aromatic protons and coumarin ring. You know, aromatic protons are present on this aromatic ring. Now all these aromatic rings will never want to leave the proton. So that is not correct. Now next one, protons and hydroxyl group at 4th position. Now look at them. See 1, 2, 3, 4. Usually when it is in enol form, it has a proton here. But thermodynamic stability wise, it will exist in keto form. So that is not answer. Now what is left? Methylene protons on the substitution at 3rd position. So this is the 3rd position and this is the methylene proton. Look at this. This methylene proton, if it comes out, it leaves an electrons which are stabilized with this resonance structure. So this is a resonance structure, this is a resonance structure, this one is a resonance structure. So when you have this kind of canonical forms of resonance structure, that indicates it confers stability. When there is a stability parameters are there, the hydrogen comes out as proton. So the answer is this one. So the methylene proton on substituent at 3rd position. The methylene proton at this 3rd position, 1, 2, 3, acts as an acid. So this is a concept oriented question, which to answer this you need to know the structure and you need to know the concept of acidity. Moving further, next question. Now from here onwards the questions are related to pharmaceutical analysis. Now the principle of liquid-liquid extraction is, say liquid-liquid extraction goes on like this. You have a component with one solvent, you add one more solute and mix them, then the component, the red particles and black particles will get partitioned between these two solutes. So after shaking it, when you separate one of the layer will contain only one molecule. So you can separate mixture of molecules by using a principle called partition. The molecules which are there, they will get partitioned between two of the solutes. This principle is there in liquid-liquid extraction. So the principle is partition. Moving next. See again the principle of gas-liquid chromatography. Now when you see gas-liquid chromatography, the chromatography has got a mobile phase and stationary phase are there. In case of gas-liquid chromatography, the mobile phase is a gas which contains your analyte which is to be tested. The sample which we are going to be tested is mixed with this mobile phase or gas. Now the stationary phase is a column. See the liquid absorbed onto a solid support. See this is liquid. it is adsorbed onto a solid support, act as a stationary phase, and this gas which is containing analyte is passed through this column. Now if the analyte has got more affinity towards this gas, the analyte will come out easily. If it has got more affinity towards this stationary phase, it will go and get adsorbed here. So what is happening here? Again, the analyte is getting partitioned either between this one, the stationary phase, or between this gas. So again, this is a kind of partition chromatography. So these are all simple principles. If you understand the chromatography concept, you will get these principles. Moving to the next one. See, when an electron with a charge of 1.6, this much, is moved through a potential difference of 1 volt, the energy expended or released is called. So this is a classical definition of electron volt. So the definition itself says that it is moving, the electron is moving between 1 volt potential difference, and that is what is called as 1 electron volt. Next one. See, the solvent used in NMR spectroscopy with highest level of deuteriation among these is, say, deuteriated chloroform. Now let us understand about these things. See, CHCl3 is chloroform. When you say deuteriated, in place of hydrogen you will get deuterium. Deuteriomethanol, CD3OD is deuteriomethanol because CH3OH is methanol. Deuterium oxide, G2O, whereas deuterioacetone, this is CD3, C double bond O, CD3. See, acetone is CH3, C double bond O, CH3, and all the protons are replaced with deuterium. Now when you see here, you have 1 deuterium is there, here 4, here 2, whereas here 6 deuterium is there. Now what is the question? The solvent in NMR with highest level of deuteriation. Among all this, where do you find highest amount of deuteriation? With the deuterioacetone. So the answer is 4. Next one. What is the approximate chemical shift ranges for protons attached to aldehydic groups? See, this is again NMR1. You need to understand the chemical shift. See, the general logic of chemical shifts is, if the proton is attached to highly electron withdrawing group or a molecule with high electronegativity, the proton signal occurs at higher value. Now look at them. See, alkanes, the proton is attached to a carbon which has got very less electronegativity, so they occur at this level. When you keep moving down, aromatic protons, see, the aromaticity will try to get the electrons, and the hydrogen value occur at this 6 or 7 levels. Amide, aldehydes, carboxylic acid, the moment the proton is attached to high electronegative atom, the signal occurs at this higher values, and it is 9.5 to 10. Aldehyde, the signal occurs at this value. Next one. Closeness of measure value to the true or accepted value is known as. So this is a general word in analysis. You do an experiment, if the experiment result comes very closer to the standard value, it is called as accuracy. Now, accuracy is closeness of a measure value to the true or accepted value, whereas precision, when you do multiple experiments and you are getting multiple values, if all of them are very close, then it is called as precision. But here the question is about closeness of a measured value to the standard value is known as accuracy. Moving further. Now, Globar source infrared spectrophotometer is silicon carbide rod. It is a direct question. Thank you for watching this video. If you like my video, do subscribe and do comment. Thank you.